Hey guys, in this video I'm going to tell you how the data are represented in the form of numbers for various symbols, alphabets code for information interchange, which are basically used by all of the worldwide networks. So let's see what we are going to have in our video. Number one is what is data representation, about its type, number conversion from decimal to binary, what is ASCII and ISCII, alphabet representation in binary code or ASCII code, how to decode an information written in binary, and what is Unicode. Oh, we are having a very interesting topics. Let's see. Data representation chart. I have given this basically for your visualization that how we can categorize our information in various different parts. So you can see data representation is just a representation of any number, any information in digital form, and you know what is digital form. That is 0, 1, 2 digital representation. So here we have given decimal, binary, octal, and hexadecimal. So let's see what is decimal number system. When and why the data are represented in decimal number system. Let's see. Decimal number system, as the name suggests, it would maybe have 10 symbols or any numbers. So, but still it has 10 symbols. It has 10 symbols numbers which are 0, 1, 2 to 9, and because it has 10 numbers and 10 symbols, it has given a base 10. Means whenever a number or any code which is written as with base 10, you can easily simplify it that it is a decimal number system. And it's a positional value system, a very important point. Positional value system means the value of any number, any code, any information written in decimal number system is depend upon its position. Means for example like 729, so 7 represent 100, 2 represent ones, 9 represent ones. So this is how the value of a number depend upon. Here we have binary number system. Binary number system is one of the number system which are presently widely used all around in all the computers in all the networking system, because it is a very easy system, or it does not create lot of duplicate files, etc. वगैरह. Positional value system means as I have already told about decimal number system, same condition will be applied here, and stores all the data and instruction in the form of 0 and 1. Means it has only two symbols, 0 and 1. The binary number system or info stores all the information like your photo, like your video, your instructions, your codes, your programmings, anything. It will store in 0 and 1. And it is a because it has two symbols, so it is given as base as 2. So most widely using computers, and octal and hexadecimal. These two are also very important in computers, but most of the companies does not prefer to use them, but still they are useful. Let's see octal. As the name suggests, it would have 8 unique characters from 0 to 7. It does not include 8 and 9. And useful in representation of symbols and alphabet. Yes, of course. Hexadecimal uses 16 symbols and characters which are 0, 1 to 9, and from 10 to 16 it does not include number. It uses A, B, C, D, E and F. That's why it is hexadecimal number system. Very interesting and very complicated. It includes numbering of data using numbers like if you want to represent 36, you will not just simply write 3 and 6, you will write 3F. If you want to represent 31, you will write 3 1. If you want to represent 30, you will write 3A, like this. And let's see the interesting topic you're going to have in our video. This is number conversion from decimal to binary. Let's see, like we want to convert 20 into binary. I'm just taking those examples so we can easily understand what does mean. So simply you need to do the division here. You need to divide all the numbers, whatever be the quotient, whatever be the remainder, by 2. Means here the our quotient division dividend is 2, 20. You need to divide by 2. So 20 when divided by 2 gives the quotient as 10. You write the quotient on down to 20 and the remainder on its right side. Then again divide this by 2, the quotient on the down to 10 and the right side would be written as remainder. Same to the for the rest, and when your quotient comes as 1, you just stop your division and just simply, so your binary code for 20 is 10100, means from down to upward it will goes from down to upward. You have to take your code from down to upward. Let's take some another example, that is 21. So simply here you have to do the same thing. You need to divide this by 2. Whatever the quotient you need to write on the down to 21 and the remainder should be on the right side. Again divide this by 2, quotient on down to 10, the remainder on the right side. Do for follow the for same, and when the your quotient comes as 1, you cannot divide 1 by 2, so just stop your division. Again from down to upward count, take the digits, and you will get as your code for 21 is 10101. And if you say follow the same pattern. Now here, as we have learned all the things for conversion of decimal to binary, let's see how can we convert our decimal number into binary number. It would be important for our visualization. Let's see that we have as taken our example 10101 and we need to convert into this as decimal. So here we will take 101011 each number at a time, means for this one you will need to take 1, as we have divided each number by 2, so we need to multiply this by 2, and this is as a power raised to the power 4. Why? Whatever be the count on its from 1 to on its right side, whatever the count, you need to take it as a raised to the power of 2. As I from 1, it's on the right side with the raised power is 102, sorry, 1 2 3 4, its count is 4, so you need to take a raised to power as 4. Now take this as 0, so this 0 will be here, it will be multiplied by 2, and whatever the count on right side, that is 1 2 3, it will be its raised to power 3. Similarly same pattern here, you need to take 1, multiply this by 2, and then whatever the count on its right side, that is 1 2, it would be its as raised to the power 2. Same pattern follows for the rest of the numbers. When you solve this, you will get this, and when you add up all these numbers, you will get as 21. Same number we have taken in our decimal to binary, and same number we have taken from binary to decimal. So you can see this. Now let's take one more example, that is 101011 into decimal. Simply take this 1, multiply this by 2. Let's count the numbers on the right side, that is 0 1 2 3 4 5. 5 numbers are on its right side, so then take its raised to the power as 5, then add up, then 0, then multiply this by 2. Let's count on the right side, that is 1 2 3 4, take it raised to the power as 4. Same pattern follow for the next all the numbers. When you solve, you will get these numbers, and when add up, you will get 43. So this code represents 43. So let here we have talked about all the representation of numbers into binary or binary into decimal. Let's see how the alphabets are represented in binary numbers. So for this ASCII code, that is American Standard Code for Information Interchange, has been introduced. In this, it is a 7-bit code, means it includes 1 0 0 0 0 0 0, 7 numbers. It has 2 raised to the power 7, 128 possible outcomes. Listen, we are taking this 2 because we are taking as a binary, and we are converting all the numbers into binary and binary to decimal. So we need to divide every number by 2 because it is a base 2 number. So don't be confused why we are taking only 2. Okay, and it has the capability of representing all the keyword characters like A to B, or bracket, symbols, quotes, bracket, simple square brackets, ask hashtag, at the rate of, dollar, percent, etc. and all the control function like shift, enter, up, down, up, etc. So let's see the alphabet conversion of into binary, or you can say ASCII code. Yes, it is ASCII code. So for this we need to write from A to Z our alphabets and given its count. A equals to 1, B equals to 2, C equals to 3, like this, and Z equals to 26. As we know, our total number of alphabets are 26. Like this we can do. So for A, so we cannot divide this by 2. You can simply say that, yeah, when your question becomes as 1, you cannot for do the um, division. So just you need to add up this simply with these numbers. These numbers you let's I want to tell you that this number is a ASCII number. ASCII, this is 7-bit code, as I have already told. The 7-bit are these numbers. These number represent the 7-bit code, and you need to add up all this number, that is 1, because we cannot divide this 1 by 2. So you need to add up this 1 by this, then you will obtain your ASCII code for Z, for A. And let's see some another example, that is 26. You cannot add up 26 directly to this number, because yes, we can divide 26 by 2, follows all the division. So just divide 26 by 2, you will get whatever be the question right on down 26, remainder on its right side. Again divide this 2 by 2, follow the same pattern for the rest. When your question comes as 1, stop your division. From down to up, take your numbers. Your ASCII code for Z will be 11010. This is your binary code, and you will add up this with this number, that is 7-bit ASCII code. You will get your alphabet binary code for Z. This is your alphabet code for binary Z. And let's take some real life example. Real life example, I have taken this keyword as real life because here, because we are going to have some examples which are used in our day-to-day life, like for information interchanges. How can we decode our information? Simply, you can say the information written in binary. Then how can we decode this? Let's take this. These are the information written in binary. You need to decode this information. So, as I have already told you, these are the information written in ASCII, because just it is a 7-bit code. So you need to, what you need to do is you need to just neglect this one. This one represent ASCII code, so you just neglect this one will not have any value. So just neglect this. You will have to take from all the numbers except one. So for this, you first take the alphabets from A to Z and just count all the numbers given its count. Then simply do the same pattern. I have not taken this 0 because whenever we multiply any number with 0, we will get 0. So just I will neglect these two also. So I have taken this 1. 1 when we multiply by 2, what the count on its right side is 3. So I have taken this raised to power as 3. Again, I have then multiplied by this 0, then multiply by 2 and the raised to power 2. Same pattern I follow. When I do the sum, I will get 8. And for this one, neglect this, and these 3 0 will get us 0. When we multiply to 0 by any number, we will get 0. So I'm not talking about those. So I'm just taking 1. So when I have 1, I have multiplied this by 2. What is the count on the right side? That is 2. So I have taken this raised to power as 2, and I do the same for these two numbers. I have get the sum as 5 when after solving. So let's take for this. So when I have I have do the same. I have taken 1. I multiply this by 2 raised to the power as 3, because of on its right side the count is 3. So I have taken it as 3. For and that's the same pattern I have followed, and for this also I have do the same, and I have get 16. So let's see what does 8 represent in here. Here these are the decimal numbers. I have converted all these number into binary to into decimal. So just not be confused in this. So 8 represent H, 5 represent E, 12 represent L, and 16 represent P. That means our information is help. So this is the way how to write information in binary in the computers, or you can say how the computer stores information in binary. See, and what another standard code for information interchange which are introduced by our Indians. This is Indian standard code for information interchange. It is useful in representing Indian languages. This is why this standard code is being introduced, because we cannot with the ASCII code we cannot introduce our Indian languages to convert in binary. So for with the help of ASCII we can convert Indian languages to in binary, or you can say decimal. It is a 8-bit code. It does not include 7. It is a 8-bit code. Means one will have more 7 zeros more. So capable of representing 2 raised to the power 8 means 2 raised to the power 8. Very same for binary conversion. 2 raised to the power 8. You will get 256 possible codes. And this was introduced as I have told. And the whole process of conversion is same as ASCII. So don't be confused. Anything you want to convert, just convert by specifying a count to it. Count means a number to it. So now after ASCII or ISCII, we have one more to learn, that is Unicode. Unicode is just simply unique code, or you can say unique number for each and every characters. When data is transferred across the platform, the risk of data corruption is very high, because two different OS can use the same number or two for two different characters, or the two different numbers for the same characters. So in this case, the risk of data corruption is very high. So for overcoming all these, Unicode is being introduced. Unicode provides unique number for each characters, and it is a platform independent. Sorry, I have by mistake I have written corruption, so don't be confused. This is wrong. Corruption is wrong. Just take it from all to each characters only two. So it is a platform independent. It does not depend on the platforms. And Unicode enables a single software, or you can say single website, you can say single mobile, single network, anything to be targeted once at a time. So thank you so much for watching my video, and I hope you like this. And if you like, then subscribe too. Thank you. Bye.